Hey guys, last one here for polar. So we're looking at the area between two sections, or the area common to two different curves in polar. All right, so when we were doing with functions, it was always just, the top curve minus the bottom curve. But now that we're working in polar, sometimes the top curve and the bottom curve are part of the same curve, and we just need different times that we're in each section. So the bounds just kind of change. So for instance, find the area of the region lying between the inner and outer loops of the limicon. Limicon just a shape that looks kind of like a lima bean. This one has an inner loop. Some of them do, some of them don't. Not important if you know the names of the shapes here, guys. So we have r equals 1 minus 2 sine of theta. All right, so we need to figure out when is it in this inner loop and when is it in the outer loop. So what we can do is we can find the area of the outer, and then we can subtract from it the area from the inner loop. All right, so we just need to figure out when we're in the outer, when we're in the inner. And remember, the area here in polar is 1/2 the integral from alpha to beta of r squared d theta. Kind of rhymes. All right, so here's our function. So if we start graphing that, well, let's just take a look at the graph of this. So if we just draw out our radius and theta axis here. So we have 1 minus 2 sine of theta. Like, so if we plug in 0 for theta, sine of 0 is 0, and we're up at 1. So we start off up there. All right, the next one I usually plug in is pi over 2, and at pi over 2, sine is up at 1. So it'd be 1 minus 2 times 1, so 1 minus 2 would be negative 1. So at pi over 2, we're going to be down here at negative 1. All right, so sometime we're going to go between the two of them like that. So somewhere we're going to cross 0 here. So in other words, we're going to start off at 0 out like this, and then we're going to come in till we hit 0 right there. So that's going to be where this little inner loop starts, is when we hit 0. So if we set this guy equal to 0, we get that sine of theta equals 1/2, right? If this equals 1/2, 1 minus 2 times a half would be 0. So we actually get that theta there, 1, 2, square root of 3, is pi over 6. All right, so this guy starts at pi over 6. Right, so we didn't have the graph, there it is, starts at pi over 6. All right, so that's where our inner loop would start, would be at pi over 6. All right, now, we can do one of two things. We can go all the way around the inner loop and figure out where it stops, or we can go halfway and then just double it. It might be easier just to go halfway. So if we go halfway, it's actually, so at pi over 2, we are down to negative 1, which is right down here. So this is actually where we are for pi over 2. So we can just go to pi over 2, and we've got 1/2, and that will do this half of it right here. It'll find that area. And we want double that area because we want both sides. So we can just double that. Our radius is just this guy right here. So it'd be 1 minus 2 sine of theta quantity squared d theta. So that's the inner area. Now let's try and find the outer area. All right, so if we keep going from here, when we hit pi over 6 or 5 pi over 6, we're back to here. So that means we'll start doing the outer area when we hit 5 pi over 6. And that'll be right there when we're back to 0. All right, now we'll keep going up for a while till when we hit pi, and sine of 0 is pi, so sine of pi is 0, so it's back up at 1. But it looks like that would just be right there. We need to keep going until we're out to 1, 2, 3. It looks how far we get. So if we go another pi over 2, that would be 3 pi over 2. Sine's negative 1. 1 minus 2 times negative 1 is 1 plus 2. We're going to be up here. So this just keeps going up until we get up to 3. All right, and that happens at 3 pi over 2, which is actually this axis. So it's not like it's going negative or anything. So if we just keep going to there, that would get us this whole area. So this whole thing, including that little section in there, would be covered. So if we just find that whole area and double it, we'd have 2 times 1/2 the integral from 5 pi over 6 to 3 pi over 2 of our r squared. So 1 minus 2 sine of theta squared d theta. And then we're just going to subtract between those two answers. The 2's and the 1/2's are going to cancel out for both of them. All right, if we wanted to, we could go from 5 pi over 6 until this goes back down to 0 here. That would work too. And then we wouldn't have the 2 and the 1/2 out there, but that's going to work fine. And this, again, we did half of that little inner loop, so we're doubling it, and that works fine. So let's go to our calculator now instead of trying to take the integral of sine squared. So we've got the integral, math 9, from 5 pi divided by 6 to 3 pi divided by 2 of parentheses 1 minus 2 sine theta, close the parentheses, squared, d theta. So there's our first integral, 8.88126. And then we want to subtract this second integral. All right, so if we're going to plug that guy in, and we could have done this all at once if we wanted to, but I'm just doing it separately here. All right, so we're going from pi over 6, second pi divided by 6, to pi over 2, second pi divided by 2 of that guy squared. Might have been easier just to rewrite this guy and just change the bounds, but oh well, too late now. 1 minus 2 sine theta, close the parentheses on that, close the parentheses on the 1 minus that whole thing, squared, and d theta, and voila. There's our answer. So the inner loop is much, much smaller than the outer loop, which makes sense. The outer loop looks a lot bigger than the inner loop does. So we get 0.5435 and some change. All right, so we want the 8.88126 minus that last answer we got. So second answer gives us 8.3377. All right, and there's our answer. All right, it's probably something in terms of pi. I don't know what it is, but maybe we can divide by pi and c, divided by second pi. Math, enter. Nope. All right. All right, but that's good enough. That works right there for the AP exam. And there we go. All right, and the other kind of problem. So that was the area between two. This is the area that they have in common. All right, so we have two curves here. One of them is in gray, and is the heart-shaped guy, the cardioid, and that's 2 minus 2 cosine of theta. And usually on the AP exam, they actually give you the graphs for these, but you can always graph them because you have a calculator. And we have the circle. So the black circle here, which is -6 cosine of theta. And we want to know where they overlap, which would be really like a whole bunch of section here. So like it'd be like all this, and all the pink stuff, and all the gray stuff. All right, so there's a lot of stuff here. All right, so one thing we can do is, well, we can see it definitely splits into two sections. So from one of them, again, we're always going out from 0, 0 when we make our sectors here. So for one section, we'll be going out to the circle. So from here to here, we are in the circle. All right, but then from after that, we are in the cardioid. So we're going out to this guy, the gray guy, which is the cardioid, which is this graph. All right, so we're going to have two different sections. One's going to be the circle, and one's going to be the cardioid. And then we're probably just going to want to double both of them to get this part over here. But this section is where they overlap. It's kind of like a, I don't know, like an oval-ish thing, but not quite an oval. All right, so the first one, we want to know, all right, well, where does this start? It looks like it's pi over 2, where the circle starts going up, but we're not sure. All right, so let's take a look at the graph of that. So if we take a look at r equals -6 cosine of theta, and we could do this on our calculator if we wanted to, but it's just going to be r, here's theta. It starts at -6, goes up, comes back down, and then it just keeps repeating. All right, so we're starting off at -6, so at 0, the circle is actually all the way back here. We get all the way back to 0 by pi over 2. So it's actually following, I believe, this part down here, and it's coming all the way around back to 0, and it's hitting 0 at pi over 2. So that's actually where we want to start. Where we want to stop is when they meet each other. All right, it looks like it's going to be 2 pi over 3, but the way we find that is we set these two equal to each other and solve. So we're going to say -6 cosine of theta equals 2 minus 2 cosine of theta. Yeah, sure. We'll add this guy over here. We'll get -4 cosine of theta equals 2. Divide by -4. Cosine equals -1/2. And that's going to happen. Oh, I kind of drew this the other way around, didn't I? Voila, fixed. -1 to square root of 3. So this is pi over 3 in here. So that means this would be 2 pi over 3. Hey, we knew that's what it was going to be anyway. All right, so that's where it's going to hit the other graph. So that means for the circle part, which is this little gray section, is the 1/2 the integral from pi over 2 to 2 pi over 3 of our r, which is in this case -6 cosine of theta squared d theta. And now remember, we want 2 of those because we want this section down here, which is going to be the exact same area, just a different section, so times 2. There goes the 1/2. All right, next up. All right, well, I guess it's a cardioid. Red makes sense. We want this part. It actually just keeps going all the way around, but we want at least this part, and then we can double it. Times 2. All right, so to get that part, we know it starts at 2 pi over 3. So this is the cardioid area, which is in pink on the picture here. So it's 1/2 the integral from 2 pi over 3. And then it's going to stop when it's out here, and it's out here at 1, 2, 3, 4. So we want to know, when does this guy equal 4? Well, we can subtract the 2. And we get -2 cosine of theta equals 2. And then we would get cosine of theta equals -1 by dividing. And cosine equals -1 at pi. So we're going to go from 2 pi over 3 to pi of this guy is our r now. 2 minus 2 cosine of theta squared d theta. And that's just the top half. And we can double it times 2. And that takes care of the 1/2. And now we want to just add these two guys together. All right, so we'll pull out the calculator. We'll find each one. We'll add them together. We could do it all at once if we want. All right, well, I can see this one, so I'm going to do that one. Math 9. We are going from 2 pi over 3 to pi. I think the longest part of this is probably typing it in. Then we've got parentheses, 2 minus 2 cosine of theta. Close the parentheses for cosine. Close the parentheses for the whole term. Squared. There we go. D theta. There we go. And that's 14.0774. All right, so there's 4 decimal places. And remember, our answers have to be right to 3, so we need to have at least 4 when we're doing this. All right, for the other one, let's move this over. We're going from pi over 2 to 3 pi over 2, so math 9. We're starting at pi divided by 2. We're going to 2 pi divided by 3. Yep. And our guy is -6. We don't really need the negative. It's going to go away, but that's all right. I'll type it anyway. Squared d theta. Enter. 1.6305. So this guy is 1.6305, and we want to add those two together. All right, and it makes sense that like this gray section is much smaller than this pink section here. Even with the 2 of them there, it's still going to be pretty small. The pink one's going to be most of the area here, but we still need both parts. So if we add them together, so this guy plus, and there's my, oops, I pressed enter already. Shucks. Okay, I think I can just clear out this line, right? There we go. So plus, and then I want to type this other guy in, 14.07741, and so on. And there's my answer, 15.70795, and so on. So 15.708 is what that would round to. All right, so that is finding the area in common between 2 curves. All right, yeah, and I know polar's not necessarily the easiest thing. There's a lot of moving parts and a lot of trig going on here, but just try and picture what's going on. Try and find the sections you need to find. and then work out those integrals. And the integrals you can do on your calculator. The calculator is fine here, guys. All right, so that is it for polar. So take a shot at the homework. It's there.